guys, welcome to the channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have an amazing problem for you guys. I'll be talking about, it's about a pretty good problem. So the problem called find the celebrity, right? So this is a very, very good problem, guys. I love it. All right. Yeah, it says suppose you are at a party, right? And people labeled from 0 to n-1, and among them there may exist only one celebrity, right? Okay, so there's gonna be a group of people, and then one of them might be the celebrity, right? Yeah, so it says the definition of celebrity, right? Is that all the other n-1 people know the celebrity, but the celebrity does not know any of them, right? It says now you want to find out who is the celebrity, who the celebrity is, right? Or verify that there is not one, right? Okay, it says the only thing you are allowed to do is ask questions. Hi, IA, do you know B, right? To get information about whether A knows B, right? Okay, so we will ask A, doesn't A know B, okay? It says you need to find out the celebrity, right, by asking a few questions as possible. It says you are given a helper function bool, right? It's called knows A, right? So there's going to be a helper function that we can use. He said it tells us whether A knows B, right? So okay, so we pass in two parameters to that function, right? And then this is going to return a bool value, right? Boolean value to let us know if A knows B, right? That's what they're saying right there. Implement a function, right? Find a celebrity that we're gonna pretty much write the algorithm that we're about to write, right? It says there will be exactly one celebrity if they're at the party, right? Cool. It says to return the celebrity label if there is a celebrity at the party, right? If there is no celebrity, return -1, right? So pretty interesting problem. You see that they have defined to us, right, what a celebrity is, right? Which is one of the most important thing for us to grasp in this problem statement, right? So it says the celebrity is a person that everybody knows about. All the other n-1 people, right, knows that celebrity, but that celebrity doesn't know any other celebrity, right? So you can kind of see this question kind of giving you the same kind of vibe as the other problem that I did, guys, which is find the town judge, right? They're practically the same guy, the same concept to principle. They're very, very, very similar. So if you guys haven't seen that problem, it's an easy problem, but you could argue that it's pretty much the same difficulty, because the underlying topic pattern that you need for this problem is exactly the same guy. I can literally copy the code from there and paste it in there. I don't remember how it looked, but but it's the same concept, right? Yeah, so we see that yeah, and the other problem, we needed to find the town judge, right, where they said that all the other n-1 people, right, knew the town judge but trust the town judge, right? But the town judge doesn't trust anybody. But this one, they switch it up a little. They said all the other -1 people know the celebrity, but the celebrity doesn't know anybody else, right? So you kind of see it's the same thing, guys, just different changes of the words, guys. Pretty much it's the same thing, guys. So because we've done other problems like that, we're gonna comfortably be able to do this problem, right? So you can see that they pretty much show you guys that it's gonna be graph, right? A graph problem, right? So you can see that all the different people in the I'm saying, so we give it n people, right? So n might be 3, right? And I mean there's 3 people, right, labeled from 0 to n-1, right? That's their label, right? Okay, so n-1, right? So we got 0, 1, and 2, right? So we see the relationship, guys, is given to us, right? So 0 knows 1, right? That's how we show a relationship, right? So every person in the graph, right, they're pretty much the nodes, right? And then we have the edges, guys, to show the relationship between the different vertices and different nodes, guys, right? So you can see it's a directed edge, right? So I have a playlist on graphs. If you guys are not too familiar with graphs and how to represent them and do all those kind of things, right? Yeah, so if you get that something's gonna pop up, you can check that out, right? So 0 trust 1, 2 trust 1, 2 also trust. I mean, I'm tripping. I'm still thinking the same mindset as the other problem. So, 0 knows 1, right? And 2 knows 1, right? And 2 also knows 0, right? So we see that they said that so a celebrity is a person that knows, is a person that knows nobody, right? But all the other n minus 1 people, right? Which is the 2 people left, right? There's 3 people, so n minus 1 people, which is 2. Knows 1, right? They know 1, guys. So this is how we pretty much can return the answer to say, hey, this is the only node, right? It doesn't know anybody else, and everybody else knows that person, right? So we say, oh, that's the celebrity, guys, right? And pretty much the same thing right there, right? See 0, so 0 knows 2, 2 knows 1, and 1 knows 0. You see, there's not like there's none of the nodes right satisfy the criteria, right? Where the they don't know anybody else, right? 2 knows somebody, 0 knows somebody, 1 knows somebody, right? So you're pretty much not good right there, guys. So you have so celebrity is a person that doesn't know anybody, right? You could take up real life, right? Celebrity doesn't know anybody else. Everybody knows about the celebrity, right? So so you can see that we could easily solve this problem by, we see that we got a couple edges, right? So we gotta use those concept of in degree and out degree, right? Pretty much to solve this problem, guys. So pretty much the same kind of logic as we did in our problem. It's exactly what we're about to do here, right? So pretty much we could the definition given to us, right? We could translate that into a better way, you know what I'm saying, to graph, right? So pretty much what they're saying right there, guys, celebrity, I'm saying is celebrity is a person that has the n degree, right? So pretty much if somebody knows you, right, that means somebody's pointing to you. So 0 knows 1, right? 2 knows 1, right? See, they're both pointing at you, right? So now how we keep track of how many nodes are pointing, so when nodes are going into you, right, they call that the n degree, right? To see how many nodes are pointing to me, right? And then the out degree is the amount of edges going out of a node, right? So you can see there are 0 nodes going out of that node, right? So we could translate that to say there's my n degree, so celebrity is a node where the n degree is equal to n minus 1, right? And the out, so this statement, right, is pretty much saying, but the celebrity doesn't know anybody, right? In the out degree, which is the edges coming out of my node, right? So see, 1 has 0 out degree, right? So that means that yeah, pretty much we could say that and it said, but the celebrity has an out degree of 0, right? So it pretty much does not know any of them, right? So that's pretty much what they're saying. That's the translation, right? Celebrity is somebody with n degree of 0, right? Right? And n degree of n minus 1, right? And it has an out degree of 0, right? So pretty much we could easily solve that, guys. So pretty much all we need to do, guys, is keep track of the n degree and the out degree, right? So this is pretty much the easy way of doing this, guys. So you could go the other route of having the n degree, right? Just like we do for the topological sort problems as we've done this channel, right? And also build the graph, and then we could pretty much the same way I did it in the other problem, guys, where I went that route, which was I had an n degree and I had a graph, and I kept track of the n degree and the amount of out degree that was going, and we both solve it. So this one I'll make it even more simpler, right? We're just gonna use 2 arrays, one to keep track of the n degree of a node and one to keep track of the out degree of a node, guys. So just as simple as that, right? That's the other alternative way of doing it, right? You could use the same logic I'm about to use now in the other problem. It's gonna help you out a lot, right? So it's called the n degree, guys. I'm gonna call that so it's gonna be a size n, right? And the out degree, right? It's gonna be of size n as well. All right, so what we're gonna do, guys, we're gonna pretty much, so now we need to loop through all of the nodes, right? So now we have this API, guys, that we need to take care of. So you probably say, how can we build it? So how are we gonna do that, right? So the way we're gonna do it, guys, so we're gonna be making calls, right, to this API to let us know if a particular node knows this other node, right? And depending on this answer that we get, right, we're gonna, update those two arrays that we have, right? So we're gonna need a double for loop, right, to loop through things, right? Because we're only given is n, right? And there's n people, and this API is gonna let us know what to do, guys. So right now we're gonna have a double for loop, right? So that we could pass those two parameters, right? So yeah, all right. So right now, pretty much this loops through every node, and then for every node, we're gonna loop through all the n-1 people, right? That's exactly what this is for, right? Okay, because we need to check every other node to see the relationship that we have with them, right? So that's why we have this, guy. So pretty that is straightforward. So I do j is less than n, j plus plus, and over here I have you guys. We're gonna pretty much, if I does not equal to j, right? Because we don't want to do that. We don't want to compare ourselves, right? And what's it called? The nose function, right? Passing I, passing j. So if that's the case, right? If I'm not, not the same person, I'm comparing myself, right? And I know j, right? So that pretty much means, guys, the n degree of j gets incremented by 1, guys, right? Because that's one more node that is pointing to it, right? Because we're saying I knows j, right? So now we could also update, guys, the out degree of I, guys, because that's it's now pointing to a new node, right? That's why it becomes it gets incremented by 1, guys. So yeah, hopefully you guys are following that, what I'm saying. Very, very important that you guys understand what I'm doing right there. All right, okay. Let me just. All right, so now we're gonna do a last check, guy. If the out degree, right, n-1, no, I, right, if the out degree goes to 0, right? So now this last check I'm doing right now, guys, is too much, so now we've populated the n degree array and the out degree array, right? I'm saying to do exactly what it's supposed to do, right? So this is checking, right? If I knows j, right, then we increment the n degree of j by 1, and then we increment the out degree of I by 1, right? Because that's what I'm saying. And then if the out degree of, I'm saying, so now we look through every node, every single element, right? So if the out degree is 0, right, and the n degree of that element, right, equals to n-1, right, then we can safely say, guys, that that's gotta be the label that we're looking for, the node that we're looking for, guys. Let's see if we pass the small test case. All right, looks pretty good so far. Let's press submit. Let's see if we pass all the test cases. Awesome, guys. We're going to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.